These are your notes on mole fractions and manometer practice. So what is a mole fraction? So a mole fraction is just a mole to mole ratio, moles of one gas divided by the total moles of all of the gases. A mole fraction is also equal to a volume fraction and a pressure fraction. So we can use the same idea to solve for a lot of different things. I also want you to write this equation down. We know that the mole fraction times by the total pressure will equal the partial pressure of the gas in that system. So if I have a mixture of 2 moles of hydrogen, 3 moles of ammonia, 4 moles of carbon dioxide, and 5 moles of nitrogen, and if it exerts a total pressure of 800 millimeters of mercury, what is the partial pressure of each gas? So what I need to do is find my total pressure first, and then I'm going to be able to take my mole fraction multiplied by the total pressure, so my total pressure is there, and it should equal the partial pressure of each gas. So my mole fraction will be the mole of the individual gas divided by the total moles of all of the gases. So once you figure out your moles of hydrogen, then you can look at your adding up your total moles in the whole system. So we know that that's 2 plus 3 plus 4 plus 5. Then you want to put 2 over the total. Okay, your total ends up being 14. And then you want to multiply that by 800 because we're going to take the mole fraction, which is your part divided by your whole. So the mole, part of 1 mole divided by the total moles, divided and multiplied by the pressure gives us our partial pressure. So I'm going to set up all of my problems here. So 3 moles of ammonia divided by 14, 4 moles of carbon dioxide divided by 14, and 5 moles of nitrogen divided by 14. So this way I can do my multiplication, and I know that my partial pressure of all of my gases are as follows. Here we've got 114.28, 171.43, 228.57, and 285.71. So that's our partial pressure of our gases. Those should all add up to 800 millimeters of mercury, give or take a rounding from your calculator and such. So that's how you do partial pressure, mole fractions, and remember that a volume fraction and a pressure fraction are the same as a mole fraction. So the rest you will practice in class. Let's go down and talk about a manometer again. So a manometer, remember, is used to measure the pressure of a gas in a closed container. And so remember our pressure, we are either going to add or subtract the height of h. So if we add the height of h, we're looking at the pressure inside the container being more than the pressure outside. So it would be this forcing the mercury, if you will, it's not mercury anymore, but the liquid inside the container, forcing it out. So I can see here that this is greater than the outside air pressure, so I would add 760 to get 805. So then another example would be this one over here. I can see that the pressure on the outside is greater than the pressure on the inside because the outside atmosphere is pushing the liquid inside the container back towards the gas. So then I would subtract 760 and 56 to get 704 millimeters of mercury. So there's your notes on partial pressure and mole fractions. We will practice the rest in class. And then here's just the water vapor pressure table that I was referencing before, and that will come in handy when we're doing partial pressure and all together with the molar volume of a gas lab. Okay, thank you for watching and taking notes, and come ready to practice in class.